Hello everyone. Today I'll be talking about ion thrusters and the normal rocket engines. So we know little about the normal rocket engines. Like these rocket engines are propelled by combustion, which is by combusting the fuel. So this fuel may be liquid fueled or the solid fueled ones. These rocket engines are really great at giving thrust that is just enough to help lift rockets and the heavy body of the Earth's atmosphere and the gravitational pull and propel further into deep space missions. They are the workhorses of a rocket. But are they actually a really efficient type of engine? Well, the answer to that is no. You may be asking if this is actually true because you have been seeing the same combustion engine since the very beginning of the rocket science itself. And as per study, it is seen that over 60% efficiency can be attained with chemical rocket engines. This efficiency level does seem high, doesn't it? But when it is compared to another type of engine at a vacuum of space, the energy efficiency of 60% would seem pretty low. These are the ion thrusters. This is where they kick in. But a single disappointment about these ion thrusters is that they can't function well at Earth. These give efficiency over 90% but only at a vacuum. So not being able to work at Earth with the efficiency of 90%, as however the ion engines can't lift a rocket because of the really low thrust they produce. So let's see what is the basic difference between an ion engine and a conventional one. Both kind of rockets move the ship forward by making thrust. This thrust is made by propelling matter out of the back of the ship. Ion engines are different from chemical engines, that is the engines that work by burning liquid or solid fuel, in where they get their energy and how they produce thrust. Chemical engines work by combining fuel with an oxidizer that makes a gas that expands and rushes out of back of the engine, making thrust. Chemical engines are mass limited, which means that how much power a chemical engine can exhibit depends on how much fuel and oxidizer the rocket can carry. If the propellant runs out, then the rocket cannot go any more faster. However, ion engines, where they come into play, work differently than the chemical engines. Ion engines take very small amount of gas and accelerate it at high speeds, really high speeds. Unlike chemical engines, which take large amounts of gas and spew it out at a really low speed. This means that an ion engine uses a lot less fuel, and ion engines are actually limited by energy and not by mass. Therefore, running out of gas is not a problem with ion engines. The limit for ion engines is, however, where to get all the electricity to feed to the engine itself. So they are actually limited by energy, that is electricity that a rocket can carry, or how much that a solar panel can collect. When we compare the thrust produced by rocket engines, that is the chemical ones, and to ion thrusters, this may sound astonishing, as ion thrusters, the most powerful one, combined four of them, that is the Quintec T6, gives only a mere thrust of 290 millinewtons. It's 1 by 1000 of a newton. Can you imagine how small the number is? Whereas the chemical engines, that is like the F1 of the Saturn V, that's the most powerful engine ever existing still now, gives a thrust of about 6770 kilonewtons, which is 1000 times of a newton. So if you see these thrust dissimilarities, you can actually see the difference in this force production. But however, an ion engine wins the race when it comes at a vacuum of space, and it can propel objects as fast as 3 lakh miles per hour. So this is a huge amount when compared to a chemical rocket engine, which can do the same in the space or the vacuum, but its fuel run out so fast that it can't match ion engine. So it's basically like the tortoise and the hare race. The hare is like the chemical engine, the tortoise is like the ion engine. Ion engine goes like spews out its fuel so low that it can keep going on for years. But a rocket that is a chemical engine are not like that. They just like spew totally out. That's what makes these ion engines head out in the deep space journey. And this is it for today. Consider subscribing and like the video. Thank you.